So I have here a box, and inside this box there is one resistor, second resistor, third resistor, like that. Okay. Now let us call this R1, R2, R3. First of all, to talk about this box as being a resistor, we must prove that this V by that I is a constant. But actually it's quite simple, because if I call this I, the current there I, then the current that comes in here is I. So what is this potential drop? IR1. And this potential drop? IR2. And this potential drop? IR3. And so what is this potential drop? Well, it is the same as this, because these two are the same. So it is I into R1 plus R2 plus R3. So this V is I into R1 plus R2 plus R3. So clearly V by I is a constant, because V by I is R1 plus R2 plus R3 for which I? For every I. So V by I is R1 plus R2 plus R3, which is a constant, and that constant is what we call resistance. So this fellow behaves like one single resistor of value this constant, which is R1 plus R2 plus R3. Please first spend some time understanding the basic principle, because once you understand the principle, we will use it in many different ways. So I can think of these three as one single resistance, R1 plus R2 plus R3. So let us take this one example. Let us take another example. Now, I mean, no particular reason, but I'm just going to use a box that looks like this, and I will put three resistors this way. Okay. Now what is happening is that we are now looking into the box to see how these fellows are connected. Okay. I don't need to. I can see it from outside. But if I don't know what is inside, I can't figure out a formula for it. So right now I want to figure out a formula. The question is, what if the fellows inside were connected like that? First of all, is this equivalent to one single resistance? This is the same as this. The box is the same. We are just bunching all this and making it into one. So we call this an equivalent resistance. Suppose I call this R equivalent. Okay. Is it possible to find it? Well, I could send some current in. If I send some current in, some of that current will go there, some will go there, some will go there. I don't know how much. Okay, we can calculate. But it is easier if I actually talk of this as being V. Because what we want is the relationship between V and I. I am not saying you can't solve this problem by starting with I. I am not saying that. In fact, you can. You can put in I, then you can say let part of that I go there. I1, R1 goes in, into R1, I1 goes in, I2 goes in, I3 goes in, and so the total current coming in is I1 plus I2 plus I3. But the problem with all that is it's going to make a lot of mathematics happen. So mathematically it is just easier if we start by saying this is V. Because if this is V, what is that? V. And what is that? V. And what is that? V. So then, since this is V, what is this current? V by R1, which is I1. What is this current? V by R2. And what is that current? V by R3. And so this current must be V by R1 plus V by R2 plus V by R3. That is this current. And if you saw there, here we assume the current is I. We found this drop, this drop, this drop, and found the total drop. Here we assume the V is V. We could have started there also with V. Okay, we could have started here with I. Calculation wise, it's easier to start with I. Actually, it doesn't matter what you start with. Because what is our goal? Our goal is to prove that V by I is a constant. Whether you start with I and get to V or start with V and get to I, it doesn't matter. Okay, so don't think that this is something special. I could have started with I. The mathematics get a little messy, that's all. Because if I assume this to be I1, what will that be? I1 R1. Then I will say that is I1 R1 by R2. I1 R1 by R3. Then this current plus that current plus that current will be I. So we'll have to just do a bit more of messy math. This makes it look a little neater. How is it neater? V into 1 by R1 plus 1 by R2 plus 1 by R3 is I. Now we can talk about I by V or V by I. So if I said V by I must be constant because that was the question, right? V by I is 1 by R1 plus 1 by R2 plus 1 by R3 and this must be R equivalent. Because this is a constant. See, if this is a constant, obviously this is a constant. Doesn't depend on I. What's the value of the constant? This. Now usually we don't like to remember it like this. So we take it to the numerator and take that to the denominator and we say 1 by R equivalent is 1 by R1 plus 1 by R2 plus 1 by R3. And that R equivalent is there. Okay. Now the usual way these things are connected, they seem to be in parallel. So we call this the parallel connection and this one is called the series connection. Series means one after the other. Is that so far clear? Now let us first understand a little bit because usually if it looks like this everybody knows what to do. I have just derived the formula. Now in real questions what will happen is it won't look like this. It won't look like one after the other. It won't look like in a straight line. Is it still series? Yes. So what is the real definition of being in series? The real definition is first there was a resistor. The current that enters this resistor must, which will obviously exit this resistor, right? Whatever enters here and exits out of it, these two are obviously equal. At this point, it should not branch off. It should go into the next resistor. And that should not go off to the something in between. It should go in here fully. And then from here, you could have a resistor. Nothing branches off. All of it must come in here. Now this is in series. What about this? Is it in series or parallel? Series. This is still in series. It may look like it is in parallel, but that doesn't make it parallel. Because what enters, gets out and comes this way, goes here, enters this, fully goes there. There is no branching. So what makes something series is the fact that there is no branching. Whatever comes in goes fully here, whether it looks like this or like that doesn't matter, is series. If it branches, then it is it is not parallel. It is not series. So first, very common misconception, not series equals parallel is wrong. There are many things which are not series, not parallel. Series and parallel are not opposites of each other. They are different. If you are not a boy, you are a girl. Well, you can be a dog. Right? You can't assume that if you are not a boy, you are a girl. So what is this then? Right? So the assumption, if you think of series and parallel as opposite, Whenever you say this is not series, immediately you think it is parallel, there's a problem. Because many things are not series and not parallel. So what is the definition of series? Definition of series is what enters must exit without branching. So what is a good definition of series? Series means no branching. Which means the current is not distributed. If this fellow branched out like that, oops, this is not series. It doesn't have to look like it's in a straight line. It could look like this. But if I put one more resistance there, now it is not series. Is that understood? Unless you can say that that is not going anywhere, let's remove it. In which case, then again it has become series. So to be series, straight. It doesn't have to look like this. But no branching. Okay. Parallel doesn't mean branching. So then what is the definition of parallel? Let us see. Okay. Parallel, look at these fellows. All of these start at the same potential. They all end together at the same potential. So what is parallel? Start together, which means they are all branching. Obviously, if you start together, you are branching, right? Now this is not parallel. Why is it not parallel? Because they start together. They have not yet joined together. They don't end together. So if you join them like that together, and join means join with a wire. Either they can go like that and join, or a wire could join them. But if I put a resistor there, then it is not joining. Because they must all join together electrically. Same potential. Electrically doesn't matter, the distance doesn't matter, the potentials have to be the same, which means there must be a wire connecting them. So if I start together and I join together, then it is parallel. Right now I am not parallel. I am not series. Because it's not like this is coming in and going out. Right? Something is coming in and it is going out like that. So this is branching. But it's not yet parallel because it's not joined together. It's not ending together. Start together, end together, parallel. Is that idea clear first of all? Yes? So if I had something here, let's say, it looks like it is in series. Not series, not series. Not series, not parallel. Because they are, well, joined together, but these guys are not joined together. But if I join them like that, now what has happened? They are now in parallel. Why? Think of it this way, either entering this way or exiting that way, doesn't matter. Start together, except this starting in a very weird way. Starts together and ends together. That's what matters. Has it ended together or not? It has. Okay, now it may not look parallel because we are looking at parallel looks like that. Parallel means it should be parallel. Okay, very bad way of thinking about parallel, that's all. The word itself is wrong. But this doesn't look parallel, but it is parallel. Because the parallel condition is starts together and ends together. Now think about this resistor. It doesn't matter that it's going that way. You can just bend it. If you bent it, right, then how will this whole thing look? It will look like this. And that fellow is going to be bent like this. Now does it look parallel? But this is the same as that, no? Because all I did was to take that resistor. Why is that unnecessary long wire? Just bend it a little bit, bring it here, and then join it. So then that is not there. So then it is clearly parallel. It may not look parallel, but looks can be very deceiving. Is that hopefully clear to everybody? So please keep in mind, series enters, exits. What exits out of this must enter the next fellow fully, no branching. Parallel joined in the beginning and joined in the end. Suppose something is only joined in the end. No, not parallel. Only joined in the beginning. No. Branching but not parallel. Branching but not parallel. Branching and joined together again back. So then it is parallel. So parallel means this. This formula I don't like very much. You need to know it. 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. I am assuming you know this. Yes. But let us write this for two resistors. If I had just two resistors instead of 3, then it will be 1 by R1 plus 1 by R2, which is R1 plus R2 by R1 R2. And if I invert this, I will get R equivalent is R1 R2 by R1 plus R2. Now we are going to face parallel so many times, it's worth remembering it like this. What if I had 3? Well, if you had 3 straight parallel, please use that. But many times you will not see 3 things together. You will see 2 things together. Now every time you have to do a 1 by R, you are going to waste a lot of time calculating. Quick check. You have a product and you have a sum. Now you can get confused between R1 plus R2 by R1 R2 or R1 R2 by R1 plus R2. But just think for a second and you won't get confused. This has to be ohms. Ohms gives me ohms square by ohms. Ohms. So you must have a square at the top and you must have one term at the bottom. Okay, so it has to be R1 R2 by R1 plus R2. And where is it this most useful? Let us think about where is this most useful. Suppose I had 2 equal resistors, which happens many times. So let us say that this was 8 ohms and 8 ohms. I want to basically replace it by one resistor. So I will write it as 8 into 8 by 8 plus 8. 8 into 8 by 2 times 8. So it will be 8 by 2, which is how much? 4. So this is equal to 4. If these two are equal, it will be R into R by R plus R. R into R by 2R. R cancels, R by 2. Okay. So if you had 2 equal resistors, it will become half. If you had 2 equal resistors in series, it becomes double. Now, for series, we don't need to worry too much because you'll just simply add. It is really the parallel that you'll have to worry about the formula, because R1 R2 by R1 plus R2 sometimes can get a little messy. So let us quickly calculate a couple of things, just mentally, so you can get an idea. Suppose I had 2R in parallel with R. 2R and R in parallel. So what am I saying? I am saying R, 2R and R. What will it be? 2R square by 3R. So 1R cancels out. So what is it? 2 by 3R. Okay. Suppose I had 2R and 3R in parallel. 6R square by 5R. So 6 by 5R. So always remember, it will end up with an R because it has to end with ohms. Okay. If you, of course, you didn't have R, you had ohms there, then it will be 2 ohms, 1 ohm. So 2 into 1 will be ohm square by ohms. 1 ohm will cancel out and leaving ohms in the units as a unit, right? So, but you can be very sure that you will not get R1 plus R2 by R1 R2 will not work, because it will give you 1 by ohms as the final answer. So that will be 1 by R. So this works only obviously for 2 resistors, but if I have multiple, I would rather use this formula again and again. For example, if I had 8, 8, 4, 8, 8, 4, what I will do is to say 8 and 8 will become 4. 4 and 4 will become 2. So the answer is 2. So this would be a faster way to say that this is 2 than to write down 1 by 8 plus 1 by 8 plus 1 by 4. Laziness means we come up with shorter ways to solve. That's all. But basic idea is still clear hopefully to everybody, right? How to calculate equivalent resistance.